move from our last class. So what did we study in last class? Rates of a reaction. Before, in last class, we actually covered two concepts. One was the collision theory, right? More is the number of collision, faster will be the rate of the reaction. And to support collision theory, we also studied something called the surface area. You have to introduce more surface area. Now, some of the factors on which the reaction rate depended, what was those? Concentration we studied. More is the concentration, faster is the rate of the reaction. And also remember, in one graph, there is a one inverse is also there, right? Remember that if you have a one inverse, you actually get a straight line. So concentration goes up, rate of the reaction goes up. Then what did we study? Effect of pressure. If you are having reaction involving gases, then if you apply more pressure, more will be the number. See, ultimately you have to aid what? You have to facilitate the collision theory, and also you have to make sure that the surface area is also honored. The more is the surface area. Then we talked about temperature. If you increase the temperature, what happens? The kinetic energy increases, and if the kinetic energy increases, the rate or the chances of collisions are much more. The collisions which actually result in the reaction for getting initiated are known as successful collisions, and there are some unsuccessful collision also. Our job in this process, if we are interested in a reaction, is to increase the number of successful collisions. So now our chapter will slowly, we have learned about collision theory, we learned about the impact of surface area, we learned about factors affecting the rate of a reaction. Today we start to learn about book catalyst. In your book, it will be covered as enzymes. And in enzymes, we have two types of enzymes, like biological enzymes and industrial enzymes. So our syllabus talks more about biological enzymes, right? So whatever will be an important thing, I'll stop and I'll let you know. So we'll go by the content. So it says, all industrial processes, we will go line by line because everything is to be understood and then only you can make your notes. Over 90% of industrial processes use catalyst. Question is why? In industry, we always have the problem of what? Demand and supply. The order to procure time has to be shortened. If you order something on any e-com site or anything, you expect that it should be delivered as quickly as possible. So there are some chemicals whose requirements are in huge quantity. One of the chemical that we will study further going ahead would be ammonia as well as sulfur dioxide. These are chemicals which are used in fertilizer industry, explosive industry, then it can be used in pharmaceuticals. You have huge requirement. There's formed something called intermediates, without just like cooking oil. If there is no cooking oil, the whole society will go for a toss. So there we have to have processes which can be done in economic. Economic means you can't spend too much of energy. Let's say the reaction is highly endothermic, needs a lot of energy. Is there some way that I can reduce the energy and yet increase the output? Or the reaction happens in too much of conditions which are very costly, say high pressure. For when we talk about high pressure, it seems very easy. High pressure matlab pressure बढ़ा दिया. Have you thought to conduct that high pressure, the equipments that you have to build have to have so much of metallurgical tolerances? Like in our house, when we cook, say, not chicken, I'll say, mutton, or you boil aloo, what do? You use the pressure cooker. The pressure cooker is a pressure device. Look at the cost of the pressure cooker. It's a thick device. So when you're doing, and the pressure cooker is cooking at a hardly anything pressure, at around a pressure of 1 or 2 atmosphere. We are talking about 400, 700 atmosphere reactions. These are like bomb. Plus the reaction should also be safe. Conducting a reaction of 400 atmosphere, suppose something goes wrong, it's like a bomb exploding. So what we do, our industrial processes will use catalyst. What is catalyst? Someone who expedites the rate of the reaction. Here we will not talk about someone who reduces the rate. Anyone who reduces is known as an inhibitor. Okay, a catalyst is someone who will always expedite the rate of the reaction, but yet himself will never react with the reaction. So it creates, what do we understand from that? It must be creating certain conditions in which the collision theory must be honored. Yes or no? Because reactions happen by collision theory. So after using catalyst, my reaction rate increased. That means somehow or some way, collision, surface area, these things should happen. Means in other ways you can say, suppose I'm reacting two of you, or I'm trying to have you to indulge into a talk. Right now, if you see geopolitics right now, USA and China has appointed a new person who will now talk for the trade terms for USA. That guy is like a catalyst now. Two people who are not reacting Can there be somebody who can create a platform where some amicable decisions can be taken? Lock-ons is not the way to do business, right? So catalyst chemically doesn't change itself. In the laboratory, the effect of catalyst is observed in decomposition of hydrogen peroxide. So hydrogen peroxide is H2O2. Hydrogen peroxide is not good. Our body produces hydrogen peroxide in the liver, and immediately, you know, there is a catalyst in our body, which will, biocatalyst, which we'll study later, that will immediately break this hydrogen peroxide into what? Hydrogen, water, and oxygen in the liver. The moment hydrogen peroxide is created, it's broken down, right? So the rate of decomposition at room temperature is very slow. These are, just 1 minute, huh? Just a minute, kiddos. I think. Yeah, it's okay. I thought, have I opened the previous version? No, right, fine. So the rate of decomposition at room temperature is very slow. Hydrogen peroxide, this is a decomposition reaction. What is a decomposition reaction? A reaction in which they are always endothermic. A reaction in which one substance breaks down to give two substances. That is known as a decomposition. AB breaking down to A and B. This decomposition at room temperature is very slow. Now there are two ways: increase the room temperature. If you increase the room temperature, how do you stay in that room itself? That's also a question, right? So when black manganese, there are substances which can speed up this reaction. One being manganese 4 oxide. 4 oxide means here the oxidation state of manganese is how much? +4. Oxygen is how much? -2. So what should be the formula you try to think? Oxygen should be MnO2. MnO2 means then oxygen becomes -4. Manganese is +4. It becomes neutral. Have you understood? Manganese 4 oxide. When black manganese 4 oxide powder is added to hydrogen peroxide. So this is the general reaction which you write. But so far in our learning, we never spoke about the time that this reaction takes. This reaction takes a lot of time. So if you add manganese 4 oxide powder to hydrogen peroxide, oxygen is produced rapidly. And we will see this reaction later. It is happening in our body, but your body cannot accept this manganese 4 oxide. This is industrial catalyst that we are talking. Okay. The rate at which this occurs can be seen by measuring the volume of oxygen produced with time. So if you allow this reaction to happen on its own, you measure how much oxygen you are producing, one of the product, measuring the gas will give you a rate at which the reaction is going. So once we add manganese 4 oxide, we will see that the rate of production of oxygen has increased, which tells me, how do we measure the rate of reaction? Either by the decline of the reactant or by the increase in the content of the product. And whenever a gas comes out, it is much more easy. Allow the gas to come out through a piston. As the piston keeps on moving, you get to know that more and more gas is being produced. Have you understood this much? See, this chapter can have very small questions which will be based on your understanding. And theory is more dangerous than numericals. So your grasp has to be very good. If you don't understand anything, please do ask. How do you measure a gas? A gas can be measured by allowing the gas to get trapped in a piston. And as the rate of the piston moves, you get to know that more and more gas is being formed. Let me actually give you one balloon to blow up and give her one balloon to blow up. How do you know who is blowing up the balloon faster? By the way the balloon's surface area is increasing. If you give it to a kiddo, the balloon will be this much level only. It doesn't go up, right? The same thing out here. Some results from experiments of this type have been plotted in 7.12. We'll see that at the end of the day. So what you write in this, please write down this reaction. Hydrogen peroxide. The keywords in this discussion so far, you should know the definition of catalyst, children. Okay, so when you read your book, make sure you know what is a catalyst. Then you should know one example, which is decomposition. Use the word decomposition. Decomposition means bracket may keep written. Decompositions are always endothermic reactions because you are breaking bonds. Bendo is endo. Decomposition reaction. Hydrogen peroxide reaction, decomposition reaction to form hydrogen, water and oxygen is very, very slow. Catalyst in this process is manganese 4 oxide, which is black colored powder. Write the word black also. These are your keywords. If added, the reaction rate goes up. And this is diagnosed by measuring the volume of oxygen produced. An ATP question can also surf up from here. How will you measure the volume of gas? Gas volumes are usually measured by recording them in a piston, right? So some results of this experiment have been plotted in 7.12. We will see what is those. At the end of the reaction, manganese 4 oxide can be filtered off and used again, which tells me that a catalyst alters the rate of the reaction. No, better word is enhances. Alter can be either plus or minus. Enhances is a better word, and does not get affected or does not react in the reaction, because you could filter out manganese 4 oxide again. Hydrogen peroxide is a liquid, sometimes used to clean ears also. Are we fine so far? Now, the reaction can proceed even faster, means we already had a fast reaction, even faster by increasing the amount and surface area of the catalyst. So, catalyst quantity is directly proportional. You can write another note. Catalyst quantity is directly proportional to the rate of the reaction. Catalyst quantity and its surface area. Now, children, tell me a common sense. What was the catalyst used in this reaction? Manganese 4 oxide. How do you increase the surface area? Spread it up. Powdered, and after powdered again spread it up. Are you getting it? If you powder and spread up something, let's say for example, you have, this is the weather today out here, okay, and you want to make pakoras, and you take out besan, right, and you find that besan has a little bit formed lumps and all. If you want, and then tomorrow is sunny, if you want the besan to dry up properly, what would you do? It's already powdered. Won't you spread it up? You spread it up for the evaporation rate to increase. Now that's also shows that the surface area. Always remember surface area and collision. This is because the activity of a catalyst involves its surface. As I told you, catalyst will always, you can write this word, although this is like an aid to memory. A catalyst creates the platform for dialogue and discussion between the reactants. You can use like that. A catalyst will create the platform that enhances or facilitates the reaction to take place. And what is reaction? Collision of the particles of the reactants. समझ के लिखते जाइए, then we will understand. And so one more thing comes up. If it is a gaseous reaction and your catalyst is a gas and you have impurities like dust and other foreign bodies that have come up, what should be the rate of the reaction? It should come down. That's what they have written. It will reduce the efficiency of the catalyst. So whenever you're using a catalyst, catalysts are always used on nascent environment, pure environment. Because if dust or something comes up, the catalyst surface is very important. That is the catalyst is like a bed, and on this bed now these two reactant molecules find it a better place to react. So if the bed is contaminated, they will not come. Okay? Hydrogen peroxide is a liquid, yeah. Hydrogen peroxide is used in ear cleaning also. Yeah. Okay. Shall we go up now? Okay. So let's see the graphs. So the first graph, obviously, where the rate of the reaction, volume of oxygen produced against time. So the more steeper the slope, the faster is the reaction. So this is 1 gram of MnO2 and 0.5. What they're trying to show here is that if you increase the quantity of MnO2, automatically the reaction rate increases. Understood now? Anyone who has a doubt at any section, please do not hesitate. And the word they use is called poisoned. Poison means once the catalyst purity has been affected, it says it's poison. Therefore, the gas reactants must be pure. So the reactants that you are taking should be pure. In other words, we can say reaction should be conducted in absolutely pure environment. Nascent environment. NaSCENT. We use the word nascent environment. So chemists have found, what are the findings? A small amount of catalyst will produce a large amount of chemical change. So it is the X factor. The catalyst is the X factor. You know, how many of you in economics or other thing have you heard about the word called Pareto analysis? Have you heard the 80-20 ratio? 80-20 ratio works in every management and every lifestyle, behavioral somethings. 20% of the 80% impact in any process is created by a 20% contributor only. That is called the Pareto's analysis. there will be very small thing, a very 20% item. If you overlook that, 80% of your outcome will get impacted. There's something like that. Okay. So catalysts remain unchanged chemically after a reaction has taken place, but they can change physically. This is important. A catalyst does not react chemically, but a catalyst may have a change in its physical form. You introduced a catalyst in the form of solid, and later the catalyst was collected back in the form of a gas. That can also be possible. Okay. For example, a finer manganese 4 oxide powder is left behind after the decomposition. So we started with manganese 4 powder. The powder became even more finer. And this does not contradict us, because end of the day, everything should be as fine and as small as possible, because that all aids in the formation of more surface area. Catalysts are specific to a particular chemical reaction. The person who can create a truce between you and your friend need not be that that person can create a truce between other two persons. He may be disliked by both. So this is very important. Catalyst is particular to a particular chemical reaction. You cannot have a one shoe that fits all catalyst. Okay, bacha? So far. So let's see some catalysts that we will be using and in our discussion so far. These two, please note down. We will be using them. Haber's process, as of now, not that important. We will do Haber's process in detail. Just the name, Haber. Haber's process is used for manufacture of ammonia, and there the catalyst that we used is iron. Usually always in form of solids you will see the catalyst. Contact process also we will study as a part of our curriculum. This is for the manufacture of sulfuric acid. Here the catalyst that is used is vanadium oxide. Vanadium is in its 5th oxidation state, vanadium 5 oxide. These two should be down your throat. You cannot forget these two. The fourth one is something we will study in organic chemistry. Hydrogenation of unsaturated oils. That is where you are making ghee, dalda and all those things, margarine. There we use nickel. Nickel can be used, platinum can be used, palladium can also be used. NiPT/PD. Nickel, platinum, palladium.
So in the making of aluminum oxide that we did, that also has a
cryolite. So oxidation of ammonia to give nitric acid, we use platinum. These three will be there, will be coming in your chapters. These two we will study in this chapter itself. This will come in organic chemistry. Hydrogenation, addition of hydrogen. So key definition now comes up. Catalyst is a substance which alters the rate of a chemical reaction and is unchanged at the end of the reaction. Rather than alters, you can use the word enhances the rate of the reaction. Are we okay? Okay. Now the question arises, what is so funny about catalysts that they are able to make this reaction happen? So what happens, these catalysts have got certain shapes. Have you seen jigsaw puzzle? Board game jigsaw puzzle? Yes or no? So in jigsaw puzzle, have you seen the small cardboard pieces? They've all got a lock-on shape like that. So catalyst will always have these shapes, but that's what they're trying to show, the red one, the green one, and these get and cling on to the reactant molecule. The same reactant which was actually not deciding to come and collide, it will go and cling on with it. But there is a story to it. This action is going to happen only till the time there is a particular temperature. That is what we are going to read now. Let's say a catalyst increases the rate of a chemical reaction by providing an alternative reaction path. Okay, this part comes for enzymes. So let's finish this. Let's finish this part first and then we'll go there. So a catalyst gives you an alternative reaction path, which has a lower activation energy. So let's understand. Our reaction does not happen under normal condition, but when we try to increase temperature, pressure, usually temperature, then the reaction starts happening. Giving more temperature means giving a more input of energy to the process. That is more activation energy. What catalyst does is, catalyst finds that, okay, there is a traffic jam on this road. Let me take you through a bypass road. So the catalyst creates an alternate path, alternate reaction path, where the activation energy's demand is sufficiently low. Have you understood? That's why we say this reaction, which usually happens at a very high temperature, can happen at a lower temperature with the addition of a catalyst. Alternate path means it's like this. Let's say I'm having a reaction, a reaction which is a slow reaction, right? In order for that reaction to happen fast, I need the temperature to be increased, right? So what is the solution in my hand? I have only one way: increase the temperature and get the reaction to happen. If you are bringing in a catalyst, you find that this toil or hard work of increasing the temperature is taken away, it's obscured. The reaction still happens at a lower temperature. Isn't it beneficial for you? Yes, in terms of energy demand and expense, right? So what was the role of that catalyst? The catalyst created an alternate reaction path. A reaction path means what? A reaction pathway is whenever a reaction should happen, there has to be a minimum amount of energy that you have to supply, without which the reaction does not propagate. That energy is known as the activation energy. Carbon in the form of coal is kept in my balcony. Do they burn? No. I have to heat it. That is the activation energy. Are you getting it? That activation energy has been reduced. So your headache has been taken away. So when you are using catalyst, I am not going by this pathway. I am going by the green pathway, not by the dotted pathway. That's called the alternate pathway. And that alternate pathway will have a lower activation energy. This is the energy index. Without the catalyst, the energy demand is more. Which energy? Activation energy. We are right now not talking whether it is endothermic or exothermic. Whatever is the reaction, carbon burns to give me carbon dioxide and a lot of what you call heat. Is a highly exothermic reaction. That does not mean you don't need activation energy. We need activation energy. Without activation energy, there will never be the reaction. So you will argue with me, then sir, process is endothermic. Yes, initially it's endothermic. But at the end of the day, when we draw the balance sheet, the heat derived is much more. So the process overall is what? Exothermic. Here we are not breaking our heads on exo or endo. What we are breaking our head is the energy demand at the start of the reaction without a catalyst, and the energy demand at the start of the reaction with a catalyst. With a catalyst, the energy demand is much less. And that, for me, as a person who wants this reaction to happen, is much more beneficial. So I say that a catalyst will always provide an alternate reaction path which has lower activation energy. Catalyst does not increase the number of collision. Please understand. Catalyst does not increase the number of collision between the reactant particle, but it causes more of the collisions to become successful collisions. Now, in our last class, we said that when a collision happens, there also are some orientations. This you'll learn in higher classes, that there has to be a particular orientation, only then the collision is successful. Say, suppose that orientation is not there, then a collision did take place, but the collision did not result in breaking of a bond. So that's an unsuccessful. So please understand, 100 collisions were taking previously, 100 collisions only will take place now. You can't expect 200 collisions to happen. But in 100 earlier, the conversion ratio was 40%. Now the conversion ratio is 80%. So a catalyst converts more unsuccessful collisions into successful collisions. So one thing again that comes in our head, catalyst must be somebody who must be saying, bhaiyo mil rahe ho to ekdam samne samne se gale milo. That story will come here. Everything gets stitched up then, right? If the activation energy is lowered by using a catalyst, on collision, more particles will go on to produce products at the same temperature. So let's ask ourselves this question. Using a catalyzed reaction of your choice, devise an experiment to follow up the progress of reaction and how effective that hydrogen peroxide reaction can be devised. Catalyst of your choice. It says to follow the progress of the reaction and determine how effective the catalyst is. So first of all, you add a little bit of catalyst. If you increase the quantity of catalyst, then automatically, but they will not give you an experiment. They will give you a data on this experiment as an ATP question and ask you. Usually the question will be either the same graph or a similar type of thing. What you should see out there is what is the rate of the reaction without using catalyst, what is the rate of the reaction after increasing the quantity or tweaking the quantity of catalyst. Also, you should also keep an eye on if this sort of a graph is kept, and then they say sketch the appropriate activation energy. So one activation energy without will be here and with here. Even for the manganese oxide, how do we say? Without manganese oxide, there is an activation energy. When 0.5 was used, the activation energy was midway. Sorry, 0.2 was used, it will be in midway. When we increased it to 0.5, it came down further. Have you understood? Any doubt till here? Clear? Now, one sort of catalyst that we will talk about is enzymes. Now, this part is biochemistry. This is not chemistry, this is biochemistry. Whatever you are learning right now, make it a point that you get every single line of your textbook studied and covered. Do not try to read this chapter initially from any notes. Read the chapter thoroughly and then read notes or make your notes also. If you read from notes, there is a chance that something you will miss out, or you're trying to understand something for which you do not have the right clarity. That's the reason I'm going line by line. Enzymes. What are enzymes? Enzymes are protein molecules. You might be knowing much better than me. This is in bio part. Are protein molecules produced in living cells, right? They are catalysts. As I say, salivary amylase is an enzyme. Without salivary, a human being takes 4 hours to digest his food. If salivary amylase was not present with us, then the same food we would have digested in how much? 20 odd hours. Everyone would have been slim. 20 hours. So Nidhi would have eaten only once in the day. Or maybe in 2 days she will eat once. Nidhi, are you awake? How many fingers? 10 fingers. Look at Ahiri. Whenever I ask anything to this girl, the other girl has a pure sadistic pleasure. Nidhi, how many fingers? And look at her smile. Big jaw smile. Understood? Okay. Now it says, these biological. Now, what are we talking about? Enzyme. So far we had a more of an outlook of industrial catalyst. Now we are going to talk about biocatalysts, because we are talking right from the human body. Biological catalysts are very specific in that each chemical reaction has a different enzyme catalyst. Our body has many enzymes. Each reaction, particular enzyme. This enzyme will not be useful in another. As I told you, a guy who does a truce between two people may not be the guy who can do truce between other people also. Enzymes, there are literally 100 different kinds of enzymes, and enzymes all have an active site. Now, what is that active site? I told you in jigsaw puzzle, which you see that circular head cardboard pieces, that is like an active site. So when you take a jigsaw puzzle piece, how do you lock on that piece with the other piece? The active site goes and locks on. The enzyme is useless for me if the active site is destroyed. And we will see that the active site does get destroyed. If the temperature goes up, the active site will be lost. And once the active site is lost, the enzyme is as good as a dust particle or a foreign intruder. समझ में आ रहा है ना? So sometimes we say, na, like too much of cloudy nights or warm days, come khao. Your digestion won't take place. You know, do you understand? Digestion rates are slowed down. I hope all of you agree with me. On cloudy nights or on very summers, if you are eating too much, then there are very chances that you will have indigestion will take place, because आपका enzymes का active site are getting damaged. And if the active site is gone, active site is something like, take a new Scotch Brite. Do you feel the roughness on it? Yes, Scotch Brite, you know, right? And then once the Scotch Brite has been used for say 4, 5, 6 days, 7 days, 8 days onwards, it just take the Scotch Brite and again move it. It looks like a smooth felt on your body. So the number of active sites have gone down. And when the active sites go down tremendously, you replace it. So let's read further. Enzymes all have an active site. The active site is a particular shape. So what is to be noted here in this paragraph so far? Please note enzymes, write down enzymes dash biological catalyst. This is your outline how you should study. Enzymes dash, even when you study bio, you should study like this, dash biological catalyst. Different enzyme, then dash different enzyme for different reaction, dash greater than 100 enzymes, Are you getting it? This is your mind map getting ready. Different enzymes, different reactions, greater than 100 enzymes. So this is one 3 or 4 sentences you covered in shorthand. Each enzyme dash active site. Each enzyme dash active site, then dash that locks on to corresponding shape in molecule, to corresponding shape in reactant molecule. In bracket, just write the word jigsaw block. To corresponding shape in reactant molecule. Shinika, did you understand? I'm an enzyme. I have got an active site. So this looks like a triangle. Say a V, A. It looks like a A triangle. So the reactant molecule will have a V slot. The reactant molecule will have a V slot. So what did we write? Each enzyme has an active site. Active site locks on to the corresponding site of the reactant molecule. And this is like a jigsaw puzzle. And this lock-on helps to break the reactant. This lock-on breaks the reactant molecule into pieces. Which one?
Cataphonic reaction builds up. Like joint two reactants will make another.
That's all possible. They are very this whole thing is highly complex. When you study when we go to chemistry in daily life and uses, we will be studying there, like starch and enzyme making together. Right. So the enzyme molecules are these red pink, they go on lock on. Now we visit our same reaction again. Hydrogen peroxide. How did we break it? Manganese 4 oxide. That was as an industrial process. So in our human body, write the name catalase, C-A-T-A-L-A-S-E, catalase. Catalase is a biological catalyst. It is an enzyme. Catalase is a biological catalyst. It's an enzyme and it is there in your liver. Hydrogen peroxide cannot be contained in our body, but the body produces hydrogen peroxide. That means you have to drain it off immediately. How do you drain it? You drain it by breaking it down into 2 products which are acceptable to your body, that is water and oxygen. The same reaction we saw as an industrial catalyst, we saw MnO2, and in your body it is catalase. Are you understanding now? Right. Now, when we talk about chemical catalyst, there's a difference between biological catalyst and chemical catalyst. So, how did we start our discussion? We started with catalyst, then we understood industrial catalyst, then we understood what does a catalyst do. So, 2-3 things we have understood from the perspective of catalyst. One, the catalyst actually creates a platform where the reactant molecule, then we understood that the catalyst actually brings down the activation energy by providing an alternate reaction path. Then we understood that in case of biological catalyst, the mechanism is all same. Catalysts are actually what these enzymes are doing. They're all having an active site that locks onto the reactant molecule and helps the reactant molecule to break down. And catalyst does not increase the number of collision, it just enhances the number of successful collisions. Its conversion ratio is high. Now, although many chemical catalysts, again we are going back to industrial catalysts, can work under various conditions of temperature pressure. Means temperature pressure is not your headache. If the catalyst demands and you can meet it, the job will be done. As well as alkalinity or acidity. This means either a basic environment or an acidic environment. I told you, some reactions you will see they will write an arrow and put an H+. H+ means this reaction is happening in acidic environment. Or they may put a OH-. This means it is happening in a basic or an alkaline environment. What is an alkali? An alkali is a base which is water soluble. Do not forget. Okay. So there are some catalysts, chemical catalysts, which can work under various combinations of temperature, pressure, as well as alkaline or acidic environment. Biological catalysts operate only at a very particular condition. These biological catalysts are super stylish. They are not like chemical catalysts that they will be working in any environment that you give. That's the reason why they say, don't eat too much. and they are very sensitive to a narrow temperature range. For example, they operate at a very small temperature range. So please write down this thing. Chemical catalysts are effective for various combinations of temperature, pressure, alkalinity or acidity. हमें ये चीज परेशान नहीं करता है. What if I am a chemical catalyst? See, chemistry and biochemistry is very interesting. अगर आप इसको मजे से पढ़ोगे ना, it's all story. And the more you understand, and you can puke properly in an exam, a marks comes automatically. Chemical catalysts do not have a worry factor with alkalinity or varying temperature pressure. However, biocatalysts or enzymes have a narrow temperature zone in which they will be operative. Narrow temperature range, not zone, range. Means the minimum maximum bar is very, very small in case of biological catalysts or enzymes. And if the temperature becomes too high, they become inoperative. And what is that too high? Something like 45 degrees centigrade. Does the temperature of a city go up to 43, 44? Yes, it does go. Peak summers. और वहां पे जाके you had full mutton biryani and rice, so your indigestion is guaranteed. Ahiri looks like she has experienced in hot marriages that she went to Kolkata and Delhi, right? Must have eaten a lot under hot and humid condition. That is buttermilk or cold coffee or juice, Nidhi? Huh?
So, in my first cousin's wedding, it was in Delhi. And all,
Ah.
there was so much of food I could only have the party.
And that's because you must have drenched out all your strength in making those Sangeet video and YouTube. Make sure, yeah, I should be also there. Huh?
It was my both weddings were my close cousins,
Huh.
so I had to do also.
So she must have designed her wardrobe 5 months before. This is this. Then photographs at these moves. I want the photograph. Then when I move, then at this moment of that lehenga, there should be one photograph. Yes or no? See how well I can read your mind. And then after that, she must have slept at night with full foot pain because all the shoes that you wear, they are not the normal shoes. And if they are heels, they must be paining in a heel, right? And then if you have a small child, then you just ask that child to sit on your feet. And it's so soothing, comfortable. And then you expect that you want to have the food also. Good you didn't have. Nidhi, you're having what? Some cold coffee or... Good. Torture of the highest order. Okay, so let's go further. If the temperature goes around 45 degrees, they denature. So we use this word 45 degrees. There will be some questions which will come on that. This means that the specific shape. Now, what is denature? Denature means the jigsaw puzzle. Now you have a naughty child at home. If the child is too naughty, what does he do? He breaks those jigsaw puzzles, those active site. After that, is that jigsaw puzzle block any use for you? No. See, such a nice story. So that active site of the enzyme molecule changes. So what happens after specific shape changes due to breaking of bonds? Breaking of bonds, in our case, weakening of the cardboard, that active site is broken. So the enzymes, you know what bonds this is saying? This is not the bond of reactant. This is the bond of that active site molecule. The enzyme molecule's active site bonds break. Why it has broken? Temperature has gone up. This means that the reactant molecules are no longer able to fit to the active site. Exactly like your jigsaw puzzle story. And the child will keep on crying, "Mommy is not fitting." It's like that. And the next paragraph talks a little bit about the economics and the industry. Are you now fine with the biological catalyst part? What catalyst did you learn about here? Catalase. Catalase is present where? In the liver. What does it do? It breaks down hydrogen peroxide immediately after formation into two compounds which are your body's or substances which your body is okay with. What are those? Water and oxygen, right? Now, a huge multi-million pound industry has grown up around the use of enzymes to produce new materials, biological washing powders. And nowadays, do you see these ads come on, right? Like new so-and-so Excel with wash boosters, antigens, active boosters. Ye mal ko pakar le. So what does this? The same thing. Biological washing powders contain, first of all, washing powders are not biodegradable. So a lot of detergents were not biodegradable. Now they're trying to do it. They contain enzymes to break down stains such as sweat, blood, and egg. Sweat, blood, and egg actually produce the worst of the stain. And they do this relatively lower temperature of 40 degree. Now understand, an enzyme is active at a lower temperature, low range. Now, if you are having, say, suppose we go to up-class restaurants. Now, in up-class restaurants was the linen, white cotton napkin, and you just open that napkin and start wiping your lips, having Indian food, producing all orange color stains, not even thinking once that how they will clean it. And once they clean it, it's sparkling white. Now, in order to clean cotton at that level, or say your white towels that we clean, if you're using a washing machine, you will try to use heated water. Thande pani mein clean nahi hoga. Because the reaction is what? These wash boost, whatever is your detergents, have to go on and stick to that stain and pull out the stain. You need more active collision, temperature has to be increased. Now, these enzymes and what they're doing, they are actually able to pull down this dirt at a lower temperature. As a result, reducing your cost or expense of washing clothes. You don't need heated water to do that. Are you getting it? What I'm trying to say? Your heated water expense is coming down. Because this washing does not need heated water. Why? Because I'm using a washing powder with a biological catalyst which has the capability to cling on to a dirt at a temperature less than 40 degrees centigrade. I hope you have got a fair bit of idea. If you heat up a geyser and the normal temperature at which the geyser water you are unable to touch, that's around 48 degrees roughly. 48 is what a geyser will heat up to. 48, 49 you can take on your body. Okay, you just shout out. So 40 degrees. There is again an issue to it. And this question comes, okay, these biological washing powders with biological catalysts always have warning signs on those. Used to be, because since they contain certain enzymes which actually do not react properly with your hands, causing a lot of rash and other things, right? So it says there have been problems associated with the early biological washing powders, and many manufacturers still place warning on their packets. You're using it like bleach. I hope you know bleach, Rin, Ala and all those are bleach, indicating that the powder contains enzymes which may cause rashes. Some customers suffer from skin rashes because they were allergic. This problem has been overcome by giving an advisory of greater rinsing. So although you are saving on the cost of electricity, rinsing means, you know, what is the process of rinsing? When you hand wash a cloth, what do? You keep it dipped in detergent, then you'll do a little bit of rub, and after that scrubbing, and then you thaw water on it and you rinse it so that entire detergent goes out. Rinsing is that process. If you actually, some people, what they do, they will not do this process properly. As a result, the moment they take the shirt out and they hang it, it will still have detergent stains on it. And nowadays, if you are not rinsing properly and you're wearing black trousers, after it has dried, you will see white stains on it. These stains are actually coming from that detergent only, and the hard water that you're using. So going further, this is for your read if you want. There are other things like in the manufacture of baby food, enzymes like proteases are also used to pre-digest the protein part. Babies have a problem to digest so much of protein. So the baby food has protein. Protease will immediately digest the protein part, in a way giving a feed to the baby which is not having that protein part. The production of yogurt, enzymes are added to partially digest the milk protein, allowing it to be more easily absorbed by the body. Yogurts are taken during illness also because it can be absorbed by the body. It's not a complex reaction for yogurt to be digested. Is this thing understood? Okay. Now, before we go on to the next section, let's see this question. When using biological washing powders, what factors have to be taken into consideration? You take into consideration that the biological washing powder, if there is any enzymes which are not skin friendly and that they can cause rash. And another thing, they are anyways to be used below 40 degree. You do not use them more. Enzymes in the yeast. Okay, let us look at this question. Enzymes in yeast are used in the fermentation of glucose, right? This is the process of making alcohol. Now, when the temperature is raised to 45, very little ethanol is alcohol, actually produced compared to the amount formed at room temperature. Now, why? Because since you have crossed The enzymes are biological catalysts. Biological catalysts operate at a very narrow zone, and the narrow range of temperature is such that you should not cross beyond 45 degrees. And since you have crossed beyond 45, the enzyme is now as good as inactive. Its active sites are lost. As a result, the enzymes will not be able to, enzymes in the yeast will not be able to break down glucose to give you more of ethanol. Have we understood? The next two parts are very important. Today we'll little bit, first we'll concentrate on something else. Rate of a reaction is very important in chemical industry. Why? Because if I'm an industrialist, all I want is my input cost should be as less as possible and my profit should be, think like a capitalist. Input cost should be as less as possible and my output should be as maximum. Also, the process should be safe, easy to handle. As I told you, 700, 800 atmosphere pressures are like handling a bomb. You will not even get the clearance from the local statutory bodies to set up that plant. So it says there are, however, many other factors which the industry needs to take care as a result, account as they manufacture chemicals such as safety and cost. In this section, we will see two industrial products. One is ammonia and one we will see sulfuric acid. Have you understood? Now I'll just give you a little bit of intro gyan, what is reversible and non-reversible. Let us just try to understand before we go into what we call further. Okay, let's say a chemical reaction. We have a chemical reaction which is like a reaction in which my reactant is A plus B and it gives me what? C plus D. Have you understood? A reaction in which A plus B reacts to give me C plus D. This is known as the forward reaction. Forward reaction. There are certain reactions in which the forward reactions happens 100% and after that the reaction ceases. Means A will be completely used up, B will be completely used up. Okay, some more funda. You know the law of limiting reactant and all. Let's say we are using coal in my balcony and oxygen. You don't expect the oxygen of the atmosphere to finish up, right? So that reaction will be written as what? C plus O2 gives me what? CO2. So how do I read this reaction? If you bring 1 mole of carbon, ensure that 1 mole of oxygen gas is present. In that case, both 1 mole and 1 mole will be completely used up and will give rise to what? 1 mole of CO2. 1 mole of CO2 is a stable product which will remain as CO2. It has no desire to go back and form again carbon and oxygen. Are you understanding? If a reaction proceeds only in one direction and ceases thereafter after the production of the products, in a sense that these products are stable, this is known as my forward reaction. So question arises, in chemical world, does all reactions stop with the forward reaction? Many don't. So let us see a common example, which reactions don't stop based on your knowledge so far. Okay. Now we spoke about something called electrolyte. Electrolyte. What is an electrolyte? A liquid that conducts electricity is known as an electrolyte. So electrolytes are of two nature. One is a strong electrolyte, another is a weak electrolyte. Right? Now, anyone who gives up iron, so let's take an acid, HCl, in its aqueous form, dissociates to give me H plus ions and Cl minus ions. Agreed? Let's take a base, say potassium hydroxide or caustic soda. This will give me potassium and will release hydroxide ion. Understood? Let's take a ionic salt. Every salt is ionic, by the way. So NaCl in aqueous will split to give me Na plus Cl minus. In other sense, if you see, I actually tested one acid, one base and a salt. So acid, bases, salt are all electrolytes. Question arises, electrolytes are also strong and weak. Who is a strong electrolyte? A strong electrolyte is one which ionizes completely. And if you remember, I had introduced one factor called alpha. Alpha stands for degree of ionization. Try to understand. If you have any difficulty, let me know. Now, this process is known as ionization. Ionization or dissociation of ions. I brought 1 mole HCl. It completely ionized to 1 mole H plus and 1 mole chloride ions. In this case, I say, badmash bachcha. Then how do you classify? What is his degree of badmashi? Sir, on a scale of 10, he is 9. That means his degree of badmashi is very high. This is properly and completely ionized. I would say its alpha is equal to either 1 or I can say it is 100%. Have you understood? So all strong electrolytes have alpha in the range of 95 to 100%. These are strong electrolytes. समझ में आया बेटा? There are weak tell me. 100% means no, not looking at it. Not looking at it. These are mineral acids. Mineral acids are strong acids. Strong acids ionize completely into their constituent ions. If you again see the property, this one is in group 1, this is in group 1, this one is in group 1. A group 1 base, a group 1 salt, and a group 1 acid I have taken. I did not take calcium hydroxide, mind you. Okay, so the ionization is 95 to 100%, whereas in weak cases, this ionization will be, alpha would be ranging into 5%. This is also an electrolyte. Can you give an example? Why not? Let's take acetic acid or ethanoic acid. CH3COOH. Now this is what this Ashmita is an organic acid. This is not a mineral acid. What is an organic acid? Any acid that you get in an organic creature. It can be a plant, an animal, or a human being. जैविक इसको हिंदी में बोलते हैं, जो जीवन वाले चीजों से आया है. Inorganic are those which you get from minerals. Now this is acetic acid which is present in where? Vinegar. What is the name of it? Keep it in your memory. This will be useful for you even here also. Acetic acid, or we call it as ethanoic acid. And its main constituent of vinegar. Ethanoic acid will ionize to give you acetate ion CH3COO and H plus. Acid means it should release H plus. This is also aqueous. This is aqueous. Okay. But after formation of acetate and H plus, children, what happens? That suddenly there is a sort of a revolt. Why did we dissociate? And what happens? Complete dissociation does not happen. So the forward reaction goes to certain extent and then suddenly it finds, no, why should we obey? A reverse reaction starts, and this is known as the backward reaction, or we call it the reverse reaction. Reverse reaction. Have you understood? So take a spherical ball on a table, look at me, and just disturb the ball. This side. Tang, 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 tang. Forward, reverse. Tang, 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 tang. It will go and hold up at some moment, seesaw and all. So there is a forward reaction, there is a reverse reaction. Ultimately, what will happen in such stage, the forward and the reverse will silently agree and an equilibrium will be obtained. And an equilibrium will be obtained. At that moment, what will happen? Look at me. This solution of acid, this is all happening in one beaker. So the beaker will have acetic acid molecules also. The beaker will have acetate ions also. The beaker will have hydrogen ions also. All of them living in a truce condition, which is called the equilibrium condition. If we actually take you Glendale children and start mixing you with say Chirac children immediately, will you go and mix up? No, you will first in a sports meet, what you will do? You will go and sit in your Glendale pavilion, Chirac pavilion. After sometimes what we do, we give one room for breakout and we send some Glendale. After some time you will see there will be an equilibrium produced. Are you getting it? Every system will have that. At that equilibrium, we say that the dissociation is 5%. जब वो state आ गया ना, you will find that only 5% ionization has happened. How do I put it in front of an experiment? Let's say I design a circuit like this. Okay, this is a small circuit that I have designed, which has got a bulb and I have got two probes. Now, if I connect these two probes, the bulb should glow. Yeah, देखिए, मजा लीजिए. If I connect these two, the bulb should glow, right? And I have put it in, say, distilled water. Distilled water does not conduct electricity, so the bulb is not glowing right now. What do? You pour acetic acid out here. As soon as you pour acetic acid, the bulb will initially glow very bright because a lot of forward reactions will happen and then starts the revolt. Kyun? Why? Why did we break? And then the reverse reaction starts. And electricity is due to the flow of ions, movement of, and the ions will reduce. Bulb will again become dimmer slowly. And after a condition, the bulb will still glow. उतना bright नहीं होगा जितना आपने देखा था, एक लेवल पे सुलह कर लेगा. This is called equilibrium. The second concept in this chapter, though we will not study ammonia, we don't have time, but these two concepts I want to cover. There is something called static equilibrium, that is something called dynamic equilibrium. What is static equilibrium? In static equilibrium, let's say this is my head. You're pushing my head from this side in physics, and you're pushing my head from this side also. Am I experiencing no force? No, I'm experiencing a lot of force. Is my head moving? No. I'm under static equilibrium. Have you understood? Chemistry will get something which is called dynamic equilibrium. In dynamic equilibrium, the overall macro properties will keep on changing. Sorry, the micro properties may change, but the overall macro will remain same. Best example, look at this example. A tap in the bathroom is actually filling up what? A bucket. Right? And there is a filling rate. And what we do, we create a hole right below and we are draining out from the bucket. So there is an emptying rate also. And this is the knob of the tap. Everything has been so adjusted that anytime Srinika comes and she finds that the level of the water in the bucket is always constant. Is the water the same? No. Water is getting poured, water is getting decanted also. Another lovely example. You have a swimming pool in your apartment. Can the swimming pool cater to everyone? No. So initially you will find in a swimming pool that there are more number of people that are going on and diving. So people will say, society mein swimming pool bahut chota hai, this. You just keep quiet. After some time you will find that there is always a constant number of people in the swimming pool inside. Maybe some 14, 15. But these people are going on changing. Once Shrinika is out, you have gone in. Once you are out, I have gone in. There are 16 people and there is a constant number of people in the periphery zone. Just observe on a fine day in a swimming pool. Initially, you will find there is nobody in the periphery, all are in the pool. Now, these pool people will come up, new people will come. So, you will find some around 15-20 people, either they are changing their gear and around 15-20 people in the pool. At the end of the day, just go and ask, did everybody get a chance to swim? Yes, everybody got a chance to swim. Because you won't be there prolonged. You will get out, somebody will get in. So we say that we have achieved this scenario of what? Dynamic equilibrium. During the production of ammonia also, we will see this dynamic equilibrium. And what is dynamic equilibrium there? There will be constant use of reactants. New products will be formed. New products will again go back and form the reactant. Again, new products will be formed. So an equilibrium will be obtained. Means iske aage wo reaction jayega hi nahi. Try to understand. I am an industrialist. I am trying to make ammonia. You right now don't know the reaction. So this will be a thought process for the next class. I want to make ammonia. But the process of making ammonia is reversible. Means the moment I start making ammonia and ammonia forms, ammonia starts thinking, why should we form? Let's break down. Ammonia is formed by reacting nitrogen and hydrogen. So nitrogen, hydrogen combine to form ammonia. Ammonia will again disintegrate to form nitrogen, hydrogen. And then equilibrium will be obtained. Why did Fritz Haber get the Nobel Prize? Because he facilitated condition in which the forward reaction will only be channelized by tweaking some parameters out here and certain catalyst. कि ammonia ही निकलेगा. लेकिन सर फिर तो रिएक्शन रुक जाएगा. नहीं, I will take out ammonia in such a manner the reaction will auto-populate. He didn't get the Nobel Prize just like that. That is what we will see here. So whenever an equilibrium is obtained, he will be shifting the equilibrium point. That is our next class discussion. Okay? Hope you understood whatever we discussed. Read up till this portion, and in next class we can again start our discussion.